Hi everyone, welcome to Chapter 4, Section 4.3. In this section, what we're going to do is we're going to learn how to name and write ionic formulas. Names of some ionic compounds, and this kind of gives you a little introduction to how we do this. Potassium iodide. So what we're doing is we name the metal first and then the nonmetal. And the metal's easy because it's just the name of the element. And then the nonmetal, if it is a single atom or element, then you just drop the ending of the last name and add IDE. So iodine becomes iodide, bromine becomes bromide, and oxygen becomes oxide. So remember that metals that form the single ion are groups 1A, group 2A, aluminum of group 3A. Then you've got zinc and cadmium, which are +2s, and then silver is a +1. So these are the metals that only have one charge, okay? One charge. They are always the same. These are your positives. All right, so there's 4 steps in naming ionic compounds with metals with a single ion. You identify the cation, the positive, and the anion, the negative. You name the cation by its element name. You name the anion by using the first syllable of its element followed by the ending IDE. And then you write the name of the cation first and the name of the anion second. So K2O. First thing you do is you identify the cation, okay? And the cation is K, which is what? Potassium. And the anion is O, which is oxygen. Okay, so we've got potassium and oxygen. And we know that potassium's easy because it's just going to be the name of its element. And then oxygen is we're just going to use that first syllable, ox, and then add the suffix IDE to it, and so it becomes potassium oxide. I know this is an ionic compound because it is composed of a metal and a nonmetal. So in this learning check, let's write the name of some of these compounds. All right, so if you want to pause and go ahead and try them and then come back, that's fine. Otherwise, we'll do them together. All right, so the first thing we do is we identify the 2 ions. So we've got calcium and we've got oxygen. All right, and so the name of this, the calcium part's easy, right? Calcium, what? Ox, and then ide. All right, aluminum. This one's easy. Oxide. Notice it doesn't matter how many oxygens there are. It's still in an ionic compound, okay? It's still just going to be oxide. All right, Mg is what? Magnesium. And this time we've got chlorine. So in chlorine, we take the first syllable, which is chlor, and add our IDE. Remember, they have more than one, some of them, but they're all just one type of element as the anion. And looks like we agree with the book. That's always good, right? Now, the second learning check, what we're going to do is we're going to write the formulas for each one like in a table form, and then we're going to write the names. All right, so we've got sodium and bromine. They both have a +1 charge, okay, so they can go together 1 to 1, right? So they would be NaBr, and that would be neutral, and we'd call it what? Sodium bromide, because it used to be bromine. All right, this one's going to be sodium and sulfur. Sulfur is a -2, Sodium is a +1, so if you remember from our other lesson, that formula would be what? Na2S. That gives us 2 pluses and 2 minuses. And that would be sodium sulfide. Sodium nitride. The nitrogen is a -3. Sodium is a +1. So we're going to have how many of that? 3. So we're going to have Na3N. And so that is sodium nitride. And so these are going to be aluminum bromide. See how I'm doing this? Trying to make this fit. Maybe you can be a little neater than I am. All right, aluminum sulfide. That's -2. That's +3. So when I do my razzle dazzle, it's aluminum sulfide. The N3 with the Al, okay, that's a -3 and that's a +3. That's kind of funny looking, but that's what that is, AlN. So that is aluminum nitride. Remember, I do this IDE ending when I have a single type of element as the second one, even if I have more than one of them, as long as it's the same element. And I think we have agreed with the book once again. It's always a joy. All right, metals that form more than one cation. Now, I told you earlier that the group 1A and 2A are always the same. They only form one charge, +1, +2 for group 1 and group 2 respectively. The transition metals, those that are in that drop-down part of the periodic table that contain these 3 metals, zinc, cadmium, and silver, those all only have that charge. Okay, that's the only charge you'll ever see. We talked about this a little bit before. Okay, the other transition metals in there can have multiple charges, so they can have 2 or more different charges. Okay, I know it's like crazy. But like, for example, copper could either be a +2 or a +1. Iron can be a +2 or +3. Lead +2 +4. Chromium +3 +6. And so we use a Roman numeral in the name to tell us which of those charges it is. Okay, so we put that Roman numeral in parentheses. That iron 2 here tells me that that's the +2 version of iron, whereas iron 3 would tell me that's the +3 version. So some of these, as I said, that are going to have more than one: gold, iron, cobalt. These, don't worry about this. It's really not that difficult, because what you do is the anions don't change. Okay, the non-metal parts of these don't change, so you can always go by them to figure out what the positive charge is. What am I talking about? Well, like if in the case of manganese fluoride, for example, let's look at that. Manganese can have more than one charge. Okay, I don't know what the manganese charge is right now. What I do know though is that fluorine is in group 7A. Okay, and it always has a -1 charge. So if I look at this formula, and the formula is MnF2, that tells me that I had 2 times a negative for a -2 charge. I've only got 1 manganese. Okay, so that means that manganese must have had a +2 charge. Does that make sense? Because that's the only way manganese could be in that formula with fluorine. So I can use the fluorine to figure out what the charge is on the manganese. Why? Because the fluorine's in group 7A. It's always a -1. And so these are over here you can see these, they're always going to be the same. These are going to be the same. Then you have silver and cadmium and zinc. They're all kind of together. They only have the one charge. The other things can have multiple charges. But you don't have to worry about memorizing these, because why? Because when they're going to form ionic compounds with these negative ions, and these always stay the same, and we can figure out what they are by looking at their groups. So it's not going to cause us a problem. So when we name compounds with these variable metal charges, the only difference is that instead of just saying iron chloride, we have to tell it if it's iron 2 chloride or iron 3 chloride. And the way you remember this is that it's these guys that are in this transition metal area here, okay? This whole area in here. Those are the ones that are going to, this blue area, that is the transition metals, and so those are the ones that we have to remember, as long as it's not zinc, silver, cadmium, or aluminum. So we determine the charge on the cation by using the anion, the negatively charged one. We, oops, lost my pen. Okay, we name the cation by its element, and then we use the Roman numeral in parentheses for the charge, and then we name the anion, and since if it's one element, we're going to end with IDE, and then write the name. So let's try iron something chloride. All right. In order to figure out what the charge is on the iron, remember, I look at the chlorine. And they like these chlorine and bromine and all those guys. All right, so I know that chlorine is a -1 charge. And I see from this formula that I have 2 of those, but I only have 1 iron. So that tells me that I've got to have a total of +2 on the iron. Okay, so then I know that is iron, and so that becomes iron 2. Why? Because the Roman numeral in parentheses tells me what that charge is. The chlorine becomes chloride, and so the ionic compound name for that is iron, Roman numeral 2, chloride. So let's name these. All right, so this one, we've got to do some figuring. So we're going to have to do a little math here. All right, so we've got 2 irons and 3 oxygens. All right, now if you look at oxygen, oxygen is in group 6A, okay? And so I know that because it's in 6A from all of our lessons before this, it's going to gain 2 electrons. Okay, or you can just look at your chart and know what the charge is going to be. So oxygen is going to have a -2. So oxygen is giving me 3 of the oxygens times the -2. That's going to give me -6 total charge. My iron, I have 2 of those. Okay, so I have 2 irons. So I'm going to have to say, okay, I've got 2 irons that give me a total charge of a -6. So how do I figure out what the charge is? Well, I take that total charge that I need, that +6, and divide by how many irons I have. And that tells me that this is the +3 iron. So I now know that it's iron 3 oxide. This is 10 chloride, okay? So I look at chlorine. Chlorine again is in 7A. Okay, so I know it's going to gain 1. And so if it gains 1 electron, that means that I'll have a -1 charge on the chlorine. I have 2 of those. So that gives me a total -2. I only have 1 10 atom. So minus 2 divided by how many 10 atoms I have, which is 1. Whoops, so it's got to be plus. Gives me a plus 2. So that tells me that that 10 is a plus 2. So I now have 10, 2 chloride. Alright, I hope this is making sense. If it's not, replay this and go back through it, okay? Also look in your book. Also remember you've got your mastering, which should have some problems like this on it as well. These are your detailed solutions from your learning checks that you can also go through very slowly and see step by step with lots of words how they are doing this. And it's the same way I did it. I just do it a little quicker. Alright. Writing formulas from the name of an ionic compound. Okay, so if they give me the name, then I can write the formula. So I identify the cation and anion, and that's easy because the cation is going to be written first. I balance the charges, and then I write the formula using the cation first and the subscripts to balance the charge. So if we look at the example of chromium 3 bromide, the cation is chrome and the anion is bromide. Alright, this Roman numeral right here tells me that I have a plus 3 chrome. Bromide is in group 7A, so I know that's going to be a minus 1. So if I have a plus 3 chrome, how many bromines is going to take to give me a minus 3? The 3 divided by 1 is going to take 3 bromines to balance that out. And so that will give me a formula of CrBr3. So put it on hold and try these if you want to, or we'll work them together. Nickel 2 sulfide. Okay, that tells me that nickel is a plus 2. Sulfur, if I look at that, I know that that's in 6A, so that gives me a minus 2. So nickel 2 sulfide is going to be NiS because they're already balanced. Zinc chloride. Zinc and chlorine. Chlorine is a minus 1. It only has one zinc, therefore it's what? ZnCl, because zinc would be a plus 1 as well. Iron 3 oxide. Iron is a plus 3. I know that from the Roman numeral. How did I know this was a plus 1 zinc? Because it doesn't have any Roman numeral in there, right? And plus, if you remember, zinc is not one of those that has multiple charges. So iron for this one, iron is a plus 3. Oxygen is what? A minus 2. So if I want to use my razzle-dazzle way of doing it, I can do this, right? And I can say Fe2O3. And if I want to check that, plus 3 times 2 and minus 2 times 3, minus 6 and plus 6. Okay? And so that should be the correct formula. And if we go through all these lengthy steps that the book gives us, then ta-da, yes, we are correct. Oh, wait. This says zinc. Oh, you know why? I messed that one up. ZnCl2. What did I not do? It wasn't. I told you it wasn't a transition metal, didn't I? But you remember what the charge is on zinc? Plus 2. I forgot that part. Okay? And chlorine is a minus 1. So it would be ZnCl2. You see where I made that mistake? I was going by just this, and I couldn't do that because zinc is always a plus 2. All right, you can go back and look and see where I messed up if you want to. You can play that over and over again if it makes you happy. All right, and that's the end of 4.3. All right, cadmium, remember, is the other one that's a +2. Aluminum is a +3. Silver is a +1. Okay, so those are the others in addition to zinc that I forgot was a +2. Okay, all right, thanks for watching. I'll see you in section 4.4.